All right, so what I'm going to do here is just kind of start from the beginning of chapter 12 and go through the main points and some example problems. So first section was 12.1, and 12.1 was all about right triangles. Okay, so after 12.1, it'd be like 12.1, 12.2, kind of 12.3. We were dealing with right angles. After that, no more right angles. When you still have right angles, two things are allowed. First, you're allowed to use Sohcahtoa. When they're not right angles, you have to use like law of sines, law of cosines, and you're allowed to use the Pythagorean Theorem. Okay, you are not allowed to use the Pythagorean Theorem if it is not a right triangle. So your standard right triangle looks something like this. You've got the hypotenuse, which is always C. Capital A and capital B can go in either spot. Across from each angle is where you label its sides in lowercase letters. All right, so Pythagorean Theorem works A squared plus B squared equals C squared. And then for either of these angles, you can take sine, cosine, or tangent using Sohcahtoa. C is always the hypotenuse. All right, so let's look at a couple of different examples here. Example 1. Example 1, let's say we are given this. We are given this fact right here, and then we're asked to find the other 5. Okay, so what I would recommend is setting up a little triangle. Set up a triangle, you know, something like this. So we've got the right angle. This is A, this is B. So cosine. Cosine is adjacent over hypotenuse. That means the adjacent side is 3 and the hypotenuse is 10. Obviously, you can assume that this is not drawn to scale. So what you do is you do Pythagorean Theorem to find the third side, the missing side. So we've got A squared, which we don't know, plus 3 squared equals 10 squared. And then we subtract 3 squared from both sides, which is 9. So A squared equals, we've got 100, 10 squared, minus 9, and that gives us 91. All right, so to get A, we just square root both sides, so this is going to be a lovely square root of 91. It's best if you keep it in square root form. Okay, so the directions will tell us to find the other 5 trig functions. Okay, so the first one, sine. Sine is opposite over hypotenuse, so the opposite is root 91 over the hypotenuse, which is 10. Then the tangent. Tangent is opposite over adjacent. I'm leaving a little spot here. That's where cosine would normally go. Then we have the 3 reciprocal functions. Cosecant, which is the reciprocal of this. So you rationalize. Remember, you multiply by root 91 over root 91, and we get 10 times root 91, and then root 91 over root, or times root 91 is just 91. Then the reciprocal of cosine is called secant. So the reciprocal of this would be 10 over 3. And then cotangent is the reciprocal of tangent, so that would be 3 over the square root of 91. But again, you multiply by root 91, top and bottom. And root 91 times root 91 is just 91. Okay, so that would be your answer for that first one. Second type of problem you could see in 12.1 is about solving a right triangle. So let's say you're given this. You're given 2 measurements here, and then you are instructed to solve the right triangle. So we're missing a bunch of pieces here. So I would, again, kind of sketch out a triangle, draw what you have. B is 45, little c is 16. We know this is a right angle, so we're still missing capital A, and little b. Okay, so capital A is the easiest one to find. You know that if you add all 3 angles together, you're going to get 180 degrees. That's just how triangles work. That's a constant rule. We don't know A, but we do know that B is 45 degrees, and C is an automatic because this is a right triangle. So these two together are 135, so we subtract 135 from both sides, and that leaves us with 45 degrees for A. Okay, so that's our first piece. A is 45 degrees, so you can throw that in there. Got that. And then we're going to use Sohcahtoa to find the other pieces. Okay, so based on either one of the 45-degree angles, now here's a little hint. This one is a little bit easier because if both of these angles are 45 degrees, both of these sides are going to be the same length. So with this one, we can just find one, we automatically have the other. So let's take A for instance. So if we look at angle A right here, we have the hypotenuse, we want the opposite. So opposite and hypotenuse means I'd use sine. So we would say the sine of A is equal to opposite over hypotenuse. So sine of 45 degrees is equal to opposite, which is A, that's what we don't know, over the hypotenuse, which is 16. So what we're going to do is we multiply both sides of this by 16. On the right-hand side, the 16s will cancel. I'll have A by itself. And then I am going to show you how you would plug this into your calculator. Okay, so first thing you want to check is you want to be sure that you are in degree mode. Okay, so we check, there it is. If you need to change it, just click on here and change your document settings. All right, so what we're going to do is we're going to type this in, 16 times the sine of 45 degrees. Okay, so for A, and the directions will always tell you to round sides to the nearest tenth. So you would do 11.3. Okay, so we got the missing pieces. And then B, remember, is going to be the exact same length in this particular triangle. We could always use Pythagorean Theorem to solve for it if they were going to be different, or we could do something like this again to solve for B. All right, so that's 12.1. 12.2 is our next section. That was on angles and angle measurements. One of the main things we did here was learning about radians, what they are, and how to convert back and forth between degrees and radians. So we have, say I give you negative 40 degrees, and you want to convert it to radians. In order to convert to radians, you multiply your degree measurement by pi over 180. Okay, and then you reduce down as much as you can, like they're both multiples of 10, and then these are both multiples of 2. Okay, so this is a negative 2 pi over 9. That's what you get when you reduce that down. Label this number 1. Second, we could go backwards. Say I give you 2 pi over 5. That would be a radian measurement. If I ask you to convert it to degrees, you actually do the total opposite. You multiply by by 180 over pi instead of pi over 180. So to go from degrees into radians, you multiply by pi over 180. To go from radians into degrees, you multiply by 180 over pi. And you'll see what's going to happen here. The pi's will cancel. 180 and 5 are both multiples of 5. So here this leaves me with 36. And so I get 72. 72 degrees would be 2 pi over 5. Okay, so you get to do that, convert back and forth. And then the last big thing we did was talking about coterminal angles. So you might have to come up with two angles that are coterminal to negative 100 degrees. And what it means to be coterminal is that they would land on the exact same spot. So just to give you a quick sketch, negative 100 degrees would go from here, it would go backward 100 degrees, which would land you like right here. So like here's going backward 90, so this is just going a little bit farther. We want an angle that's going to land in this exact same spot. So we can go from here, we can go forward 360 degrees to land here again, or we can go backward 360 degrees to land here again. So negative 100, if we go forward 360 degrees, you land at 260. That would be this angle measurement right there, which makes sense because this is 270 and this is just 10 off. Or you could go backward another 360 and you would land at negative 460. Okay, so that's how you do those coterminal questions. So that's 12.2. So we got 12.1, 12.2. 12.3, we introduced general trig. You no longer had to be inside of a right triangle. So you still do sine, cosine, tangent, and all the others. But now we could be anywhere in the coordinate system, second quadrant, third quadrant, fourth quadrant. We don't have to be tucked inside of a right triangle. So here are the new measurements that we got. Sine of an angle is defined as y over r. Cosine is defined as x over r. Tangent is y over x. And then, of course, we've got the reciprocal function, so you just flip numerator and denominator. Okay, so those are the new definitions that we used in 12.3. So we could give you a problem like this. Say I give you a point and tell you that that point is on the terminal side. Say we have the point 4, -2, and we say that's a point on the terminal side, and then you'll be asked to find the 6 trig functions. So you would plot that point, 1, 2, 3, 4, -2. So here's a point on the terminal side. So this actually isn't our angle, this is our angle going all the way around, okay? So we've got the x value, we've got the y value, you have to find the value of r, and r is just this distance right here. So you basically do just a little Pythagorean theorem, or you could do the distance formula. So r would be the distance from this point back to the origin, so 4 minus 0 squared, plus -2 minus 0 squared. So this is the square root of 16 plus 4, which is the square root of 20, and that reduces to 2 root 5. Okay, so that's r. So we've got x, y, and now this is r, so we just combine them into all 3 of these. So sine is the y value over r. And that, first of all, these will cancel, and then you have to rationalize. So you get negative square root of 5 over 5 once you rationalize the denominator. Cosine, you get x over r. These will reduce down, and then you have to rationalize. 2 root 5 over 5. Tangent is the y value over the x value, and that reduces down. Okay, and then we've got the other 3, the reciprocals. So cosecant, I'm going to take the reciprocal from here, root 5 over -1. So that's a negative root 5. Sorry, my negative sign's blending in there. Secant is the reciprocal of cosine, so again, take the reciprocal from here, root 5 over 2. And tangent is the reciprocal of cotangent, so this would be 2 over -1, or -2. All right, so those are the 6 trig functions. That's the biggest thing that we did in 12.3. And so you've got some problems that can be similar to that, but this is really the main type of thing you would see. All right, so let's move on to 12.4. 12.4 was the law of sines. Law of sines is basically like 3 different equations kind of put together. Looks like this. Okay, so remember all those capital letters are angles, all the lowercase angles, or all the lowercase letters, excuse me, are sides. So I could give you a triangle. I could give you 3 values out of a triangle. And remember, starting with section 12.4, we are no longer dealing with right triangles. It has to be explicitly stated that our triangle is a right triangle in order to use Sohcahtoa and the Pythagorean Theorem. If it's not listed to be a right triangle, you have to use rules like we have in 12.4 and 12.5, law of sines and law of cosines. So the one example I could give you right here, let's say you're given a few pieces. Okay, so if you're given a few pieces like this, you will be told to solve the triangle. So that means you find all the missing pieces. So in order to do law of sines, this is very important. In order to use the law of sines, you have to have a pair. You have to have either both of the A's, angle and side, or both of the B's, or both of the C's. So you can see here we've got a pair of A's. So we can set up sine A over A. And sine A over A looks like this. Okay? Then we also have a piece of B. So it's going to be these 2 pieces that we set equal to each other, and angle B is what we're missing. Okay, so that's where we're at so far. So we've got everything set up. The only thing we need is capital B, and I will walk you through how to get that. First, we cross multiply. So we get 34 times the sine of 30 degrees equals, cross multiply here, 17 times the sine of B. We are trying to get B by itself, so the next thing we want to do is divide both sides by 17. So this will cancel. I'll have sine B all by itself, so I'm going to plug this stuff into my calculator. Okay, so set up a little fraction. I've got 34 times the sine of 30, divided by 17, which is 1. Just a beautiful 1. Okay, so 1 equals the sine of b. Now in order to get b, I need to take the sine inverse. Okay, so sine and sine inverse cancel each other out. That's how I figure out what b is. And then I have to plug this into my calculator. Sine inverse of 1. All right, and that gives me 90 degrees. So this one actually turns out to be a right angle. Don't expect this to happen very often, but it seems that it did here. Okay, so that's a 90-degree angle. So once you find 2 of the 3 angles, so it's not like we found this one, it was given to us. We have 2 angles, we just need to find the third. So if A is 30 and B is 90, A plus B together are 120 degrees. So C must be 60 degrees. Because remember, all together they're supposed to add up to 180. So 180 minus 180 minus 30 is 50. 180 minus 90, we've got these two combined together, it leaves us with 60 degrees. All right? The thing you need to check with law of sines is to see what else angle B could end up being. So you subtract 180 minus this value, but 180 minus 90, again, just gives you 90. So there's only one possible solution for this triangle. So I have everything except for little c. So now I could set up either one of these. I could set up A equal to C or B equal to C. Let's do A. So sine A is 30 over little a, which is 17. Set that equal to sine of C, which is 60 over little c. So that's the last piece that we're trying to get. So just like up above, we cross multiply here. So I get C times the sine of 30 equals, and then I cross multiply here, 17 times the sine of 60. Okay, so I want to get this value of C by itself, so I'm going to divide both sides by the sine of 30. Okay, now whatever these numbers are, they cancel. I'm going to get C by itself if I just plug this into my calculator. Okay, so set up another fraction, 17 times the sine of 60 over the sine of 30. Okay, so we get this. So little c is equal to 29.4. The directions will always tell you to have the angles to the nearest whole number, but to round the sides to the nearest tenth, like that. Okay, so that's a great law of sines example. 12.5 was law of cosines. Okay, so first of all, you need to know these formulas. So all of them start off with a squared term, like this. Then the next part of the formula is the other two squared and added together. So this starts with b squared plus c squared. This starts with a squared plus c squared. And this starts with a squared plus b squared. Then in all of them you subtract 2 times the other 2. And then times the cosine of this angle. Okay, so those are your 3 formulas. That was just to kind of walk through and help you remember where exactly they come from. So we're going to have to use those. You can either use them to solve for this side or to solve for this angle. Okay, so same thing with this one, same thing with this one. So let me write down the example here. Say I give you three sides. So there are 2 situations you could use this in. You could use it if you have all 3 sides, because then I could plug in here, 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 and I would just solve for this. Or if I had 2 sides with the angle in between. That would be like B and C and angle A, and then you could solve for side A. So those are the 2 situations in which you would want to use this. Okay? So let's write down, so here's, in this you could use angle, side, angle, or side, side, angle. Either one of those situations, you'd want to start with law of sines. Okay, so right here, if you have 3 sides, what you have to do, and this is important, if you have 3 sides, you start with what the biggest angle is going to be. The biggest angle, and you find that using law of cosines. So C is the longest side, that means capital C is going to be the biggest angle. So we use this bottom formula right here. So this is the one that we're using for this example. So c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. All right, so this is what we're trying to solve for here is the c. So we're going to simplify up. So we get 22 squared, which is 484, equals 11 squared plus 15 squared minus 2 times 11 times 15 times the cosine of c. Okay, so I just used the calculator to get those values. Now, this is one joint value. You cannot, absolutely cannot just subtract. This is attached to the cosine c. It will stay attached to the cosine until the very last step. Okay? What I can do is I can add these together. And I get 346. And so I'm going to subtract that from both sides. Okay, so that will cancel. 484 minus 346 is 138. And then I still have the negative 330 attached to the cosine. Now I divide by the negative 330 because it's being multiplied by cosine. The only way to undo multiplication is with division. I can't subtract this because subtracting undoes addition, and this is an addition, it's multiplication. So these will cancel. So 138 divided by negative 330 gives me this value, negative 0.418, and then the 18 just repeats. So look what I have here. So 18, 18, 18, 18 just keeps repeating over and over and over again. Equals cosine c. So same thing as we did up above in the previous example, except this one was sine inverse. This one you're going to take cosine inverse of both sides. I'll be left just with angle c. Now let me show you what you want to do to get the most accurate answer. Do cosine inverse, and then arrow up and just copy paste that whole decimal approximation so you can get a super accurate answer. Okay, so you get about 115 degrees. Remember, you're going to round to the nearest, and the 7 would round up. So 115 is C. So that's one of the three angles. Then you use the law of sines to find the middle angle. B is the middle side, so capital B would be the middle angle. So now that I have a pair, I can use law of sines. So I do sine C, which is 115, over little c, which is 22, equals sine of b over little b, which is 15. Okay, so now I'm going to cross multiply, just like in the other two examples. I get 15 times the sine of 115 equals 22 times the sine of b. Remember, what I'm trying to get by myself is this, by itself, is this b. Divide both sides by 22. So these 22s will cancel, and I'm going to plug this into my calculator. All right, so, whoops, here we go. 15 times the sine of 115, and then divided by 22. Okay, so I get this value, 0.61737, blah, 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 because I'm going to copy paste it anyway. So to get b by itself, I sine inverse both sides. Sine inverse and sine cancel each other out, just like adding 6 and subtracting 6 would cancel each other out. So I do sine inverse, and then remember to copy paste, so you can get a super accurate answer. Okay, so b, this 1 would mean I stay at 38 degrees. I don't round up. Okay, so I have two of my angles, 115 and 38. So far, 115 and 38, I have 153 degrees taken care of. So I do 180 minus that to tell me what A should be. Okay? Smallest side goes across from the smallest angle. So notice A, B, C are increasing in size, which means angle A, angle B, and angle C should be increasing in size. Okay, so that is 12.5. That's law of cosines. 12.6, we did all the periodic stuff, like finding the period of a graph, and we learned how sine and cosine relate to the unit circle. Okay, so in these ones, you should know how to find the period. So that quiz that you just got back, if you see any sort of graph that's repeating, you should know how to find what the period is, what the length of the cycle. The big thing that we did in this section, though, was learning that on the unit circle, every single time you see a coordinate point x, y, x is equal to the cosine of the angle, y is equal to the sine of the angle. That's a huge idea from 12.6. So you'll have this unit circle, remember that. You'll be able to see all of these values. So like any angle that you pick, like 120. The cosine of 120 is -1/2. The sine of 120 is √3/2. And then you can even find tangent that way. Like the tangent of 0 is y/x, which is 0/1. Or the tangent of 45 is √2/2 divided by √2/2. You can do any of them that way. So for instance, based on the unit circle, I could ask you to find the cosine of 5π/3. So if I asked you to find the cosine of 5π/3, all you need to remember is that cosine is the x value. So you find 5π/3, here it is. Cosine is the x value, so it's 1/2. And then just like I was talking about tangent's a little trickier. Okay, so say I asked you for the tangent of 330 degrees. Here's 330 degrees. Y is -1/2 and cosine is √3/2. So remember, tangent is y/x. So it's -1/2 divided by √3/2. To divide fractions, remember you flip and multiply. So you multiply by the reciprocal, which is this. Okay, in this case the 2's would cancel, and I have -1/√3. But remember, you have to rationalize the denominator. So you do this. So you get -√3 in the numerator, and then √3 times √3 is just 3. Okay, so tangent is a little trickier to find, but just remember that it's y/x, and you'll be able to pull it off the unit circle. Okay, 12.7 and 12.8, I'm going to kind of combine in one. These sections were all about trig graphs. So I'm going to focus here on sine and cosine. Those are the big ones, the main ones. So I want to make sure you know how to do that. You should also, for a bonus question, know how to graph any of the other ones. So make sure you look back at your notes. Tangent, cotangent, secant, cosecant. That could pop up as a bonus question, but not on the regular test. Okay, so first one, I'll give you this equation. Okay, so here is all the information that we have. First step is to plot the midline. Okay, so here's our theta axis, here's our y-axis. The midline is +1, because this tells me that my whole graph shifts up 1 unit. So I'm going to go up to 1, and I'm going to draw a dotted line there. That represents my midline. What that means is that my sine graph is going to oscillate around this line rather than oscillating around the x-axis. Okay, so that's my midline. That's step 1. Step 2, here's the amplitude. Okay, the amplitude is 2 units. So from this line, I go up 2 units to my high point, that would be 3, and I go down 2 units to my low point, that would be -1. So again, from this line, my midline, I go up 2 units and down 2 units. That's what the amplitude tells me. Okay, so I've got all that marked up. My period. The formula for the period is 360 divided by b, and b is whatever is right here, like attached to the theta. There is nothing there technically. We consider it to be a 1, so therefore the period is 360. Okay, so here's the important part that people were kind of messing up during class. When we talk about the phase shift, okay, we need to know the 5 main points of one cycle. We are going to write down without the phase shift, okay, so no phase shift. If I didn't move my cycle, it would start at 0, just like any normal cycle does. And then since the period is 360, it would go through its full cycle and it would end at 360. It would be halfway through its cycle at 180, because 180 is halfway between 0 and 360. It would be a quarter of the way through at 90, and it would be 3/4 of the way through at 270. So notice these are all equally spaced out. It takes me from 0 to 360 in 5 equally spaced points. However, I do have a phase shift. If you look at this part right here, the plus 45 actually means I'm going to the left 45 degrees. Okay, so here's without a phase shift. Next, I'm going to write all of these points if I move them 45 degrees to the left. Okay, so 0 minus 45 is negative 45. 90 minus 45 is 45. 180 minus 45 is 135. 270 minus 45 is 225, and 360 minus 45 is 315. So now these are the values that I'm going to use to mark up my theta axis. Okay, so I'm going to do that. Okay, so I'm going to go by 45s. So here's negative 45, positive 45, 90, 135, 180, 225, 270, 315. Okay, so I'm going in increments of 45 degrees. Okay, so that's 45. This is negative 45, 135, 225, and 315. Okay, now lastly, this is a sine graph. Sine's pattern starts at the midline, goes up to the high point, back to the midline, down to the low point, and it lands at the midline. Okay, so at negative 45 degrees, I will plot a point on the midline, which I need to extend it a little bit. So right here, there's a point on the midline. At 45 degrees, I will plot my high point. Since my amplitude is 2, my high point we already marked on the y-axis is up here. At 135, I will be back on my midline, so right there. At 225, my graph will be at its low point, which is negative 1. I already marked it on my axis. And at 315, I finish the cycle back on the midline, right there. Okay, so you sketch in. Here is one cycle of your sine graph, and make sure you're extending it on both sides so that you show the fact that, yes, it's periodic. It just keeps repeating itself over and over and over again. Okay, that's one. Let's look at a cosine graph. Okay, so same 4 steps, same exact 4 steps that we had before. So the minus 4 tells me the whole graph is going to move down 4 units. So I will start by sketching my midline. So I go down 1, 2, 3, 4 units. That is where my midline is going to be. Okay, so that's negative 4. My amplitude is technically a 1. If you don't see anything there, it's a 1. So I could go up 1 unit to negative 3, or my graph could go down 1 unit to negative 5. So limited space here, smaller space than I was working with up here. Okay, so my amplitude is just 1. This right here is the vertical shift, and it gives you the value of the midline. For the period, for cosine and sine, I start with 360 degrees and then divide it by whatever is in front of the theta right here. So like here, there wasn't anything, but here there's a 3. And 360 divided by 3 is 120. So remember, this number means if you graphed 360 degrees, you would see 3 full cycles. But if we only want to see 1 full cycle, we just graph 120 degrees. Okay, so without any sort of phase shifts, I would start at 0. With a phase shift, I start somewhere else. This cycle is going to end after 120 degrees, because that's my period. Halfway between these two would be 60. Halfway between these two is 30, so that's a quarter of the way through the cycle. And halfway between these two is 90. Okay? Next, right here. This is the value of my phase shifts. Okay? Minus pi. Pi, if we look at your unit circle, pi is the same as 180. All right, so that is 180 degrees. Minus pi means I'm going minus 180, which is actually the opposite of what you think it's going to do, so we're actually going plus 180. So if I add 180 degrees to all of these values, so add 180 to all 5 of these numbers. So 0 plus 180, 30 plus 180, 60 plus 180, 90 plus 180, and 120 plus 180. Okay, so those are the new values. new values. That's what I'm going to use to mark up my theta axis. Okay? Here's a little trick for axes. If you draw a little like wiggle like that, it means you're cutting off a part of the graph. Like see here, it made sense to start at 45. Here, I don't want to start at 30 because then my graph wouldn't start until way over here. So I'm going to do a little, kind of cut off a portion of the graph. Then that way I can start at 180 and then just go up by 30. 210, 240, 270, 300. All right, so that's a totally legal move if you want to use it on your own. Otherwise, if you just start with 180, that would technically be wrong because that would tell you that this distance is the same as this distance. And this distance is 180, whereas this distance is only 30. So if you're going to shorten it, you got to do that little wiggle right there to show that you're like cutting out a portion of the graph. Hopefully that makes sense. This is a cosine graph. Cosine starts at its high point, then goes to the midline, then to its low point, back to the midline, and then finishes the cycle at its high point. So at 180 degrees, graph the high point. The high point is actually down here at -3 because of my vertical shift and my amplitude. The midline at 210 would be a point right there. Low point at 240, so that would be right down here. On the midline at 270, and then finish the cycle at the high point for 300. Okay, so this is not a very tall cosine graph. Remember, graph a little bit of it on both sides to show that it does keep going even beyond just what you've graphed. So that is one cycle of a cosine graph. Okay, last thing that we did in this chapter was 12.9. And 12.9 was the inverse trig stuff. Okay, so a lot of this is going to be done off the unit circle. So say we had like the arc sine of -√2/2. Okay, so this is saying we're looking for an angle whose sine is -√2/2. So it becomes something like this. Looking for an angle whose sine is -√2/2. So we look at the unit circle. Here's an angle whose sine is -√2/2. And here's an angle whose sine is -√2/2, because remember it goes with the y value. Okay, now we put a restriction on this for a reason. Sine is restricted to the right half of the circle. Sine is restricted to -90 to +90. So this angle right here, first of all, this is the one that we choose, not this one, because this falls within sine inverse's restrictions. But 315 isn't in the restrictions. We go from -90 to +90. So we call this -90. We call this -60, -45, -30, 0, 30, 45, 60, 90. Okay, so this one that we're looking for, we actually call it -45. And then you'll also be asked for the radian measurement too. Okay, I could also ask you for tangent. Say it was like tangent inverse of 0. Okay, that means we're looking for an angle whose tangent is 0. And remember, tangent is y over x. So if we want y over x to come out to be 0, okay, anywhere on the unit circle, none of these are going to be 0, ever. These are the only ones that have a 0. Tangent is also restricted to the right-hand side, so it could be this one, or this one. Tangent is y over x. 1 over 0 is actually undefined. 0 over 1, that's 0. So your answer would be 0 degrees. Okay, so theta is either 0 degrees or 0 radians, either way. Okay, and then cosine is restricted to the top half. So say I asked for like 1/2. You would choose this one, you would choose, nope, I'm looking at sine. Sorry, 1/2. It said -1/2, you would choose this one, not this one, because cosine is restricted to the top half between 0 and 180. Okay, very, very last thing that we saw in 12.9 were these things that you used a triangle for. So say I gave you this. Okay, so this piece right here, this refers to an angle. It's an angle that has a sine of 4 over 5. Okay, so you draw a little right triangle. Here's the angle. If the sine is 4 over 5, that means the opposite is 4 and the hypotenuse is 5. So you find the missing side. That's your first task. So a squared plus 4 squared equals 5 squared. This is 16, so subtract 16 from both sides. So a squared equals, this is 25 minus 16, so that's 9. So a is 3. It's a nice easy one. That's actually a Pythagorean triple if you remember any of those. So a is 3, so now we're asked to find the cosine of that angle. So now here's the angle we're talking about. Cosine is adjacent over hypotenuse. So the cosine would be 3 over 5. All right, so you can give it in a fraction like that, or you could plug it into your calculator and give a decimal. Either works, and you can always use your calculator to help you just to check that answer. Okay, so that's it. Remember, you'll have a unit circle. Hopefully that will be helpful. Get lots of practice with these and study hard. Of course, I'm always available in the morning if you need anything.